Okay, so we're gonna graph sine and cosine functions in this section, and then later on move on to the graphs of some other functions, right? So first and foremost, sine and cosine functions are called periodic functions, right? And there is a reason for that. So where have you heard that word periodic? There is a periodic table of elements. Why is that called the periodic table of elements and not like the orderly table of elements or the numerical table of elements?
Like they keep going. Like, you know, they're consistent.
There is a pattern. There is a pattern. What is the pattern? Right, so the periods, right? So like you have an element, right? It's an alkaline metal, and then you have an alkaline earth metal, and then you've got like a metalloid, and then you've got some nonmetals, and then you've got the noble gases. And then if you go 8 of them, the next one, you have an alkali, then an alkaline earth, then you have some, nonmetals and metalloids, and then a noble gas. And then if you go again, it will repeat. And it repeats after, every 8 elements, or afterwards it repeats after, the same number of elements, right? That's why it's periodic. A calendar is periodic because after every 7 days you have a Monday. After every 7 days you have a Tuesday. After every 7 days you have a Wednesday, right? So periodic refers to something that repeats after the same interval, right? Sine and cosine functions are periodic functions. Let's take a look at what a sine graph looks like. So if you see here on the left, this is an example of, this is a sine graph, okay? It looks like a wave. So now take a look. This one, right, the center, if I were to follow, look, it goes back to the same point. Okay? And now, right. So look at the one right before it. Right there, right? So now if you look at the purple and the blue, do you see that they are identical? Right? Do you also see that the blue went through the same cycle as the purple did, and it took the same horizontal distance, right? That's why it's periodic, because it repeats after the same length. What is this magical length? How long did it take for it to start and end? Well, it started at 0 and it ended at 2 pi. So it went to a length of 2 pi. Because it completed one cycle over a length of 2 pi, we say the period of this function is 2 pi. Okay? So now, another thing we have to take note of is the value, the y value of the sine function. At the center, it starts at 0. Then it goes up, and then it goes back down, and it goes up again. And you see how it keeps oscillating, going up and down, going up and down. But you also see that every time it goes up to the same height of 1. And every time it goes down to the same height of -1. That is the range. Okay? So the range of this function is -1 to 1. It's the range of it. Like, what's the highest value? What's the lowest value? Right. Now, so that is the graph of the sine function. The one on the right is the graph of the sine function, of the cosine function. Sorry, sine, cosine. So if you were to look at these from far, far, far away, do they look very different, or do they kind of look similar? They look similar in that that's a wave. This is a wave. In fact, okay, let's look at it more closely now. When x is 0, cosine starts here, goes down, and back up. And if you look at one before it, look here, goes down, and goes up. So do you see how the pattern repeats? And the length over the pattern, over which the pattern repeats, is 2 pi. So that is the period of the cosine. Sine and cosine have a period of 2 pi because they complete a cycle over a length of 2 pi. Now, the range is exactly the same, 1, 1. Okay, so now look at another interesting fact. Suppose this sine graph was a movable one, like I could just drag it left and right, all right? If I were to hold on to the sine graph and move it over to the left just a little bit so that that peak was on top of the y-axis, what would it look like?
It would be lower.
It would be exactly like the cosine graph. In fact, that's what the cosine graph is. It's just a sine graph shifted over by a quarter of its cycle. Pi over 2. Huh?
It's still the same length apart, but it just moved over.
The reason, yes.
They meet in
the reason why is this. Do you remember how in the last chapter we kept saying sine of pi over 6 is 30? I'm sorry, it's not 30. It's 1/2. Yeah? And what's cosine of pi over 3? It's 1/2, right? So sine of pi over 6 is 1/2. Sine of pi over 3 was root 3 over 2, remember? Cosine of pi over 3 is 1/2. Cosine of pi over 6 is root 3 over 2. So, you know, there is this relationship, right? One and the other, they're always, you know, sometimes they're equal, sometimes they're not, and so on. Okay, so here's the fun word of the day. Any graph that is generated from a sine graph is called a sinusoid. So the next time you're at your mathematics party, right? That might be the password for you to even get in.
What? How do you say it?
Sinusoid.
It's a sinusoid.
Sinusoid.
It's like,
a dinosaur.
right. It has nothing to do with your sinuses. It's a sinusoid, or you know, sometimes we say like sinusoidal functions. Those are like functions in the same family as the sine. So like all the cousins of the sine function. Okay, just fun word of the day. Here is how the sine and cosine functions look, right? That's how the equations look. In order to get an equation, in order to get something to be an equation, you need an x and a y variable. And you see here, you've got an x and a y variable. You also have some other constants here, an a, b, c, d. Each one of those has a different purpose in life. And the purpose of the goal of this lesson is to figure out what each one of those do. Okay? All right. But we're going to start slow. Do you remember the unit circle? I sure do.
No.
So here's the unit circle from before. Same thing. It hasn't changed. So here's pi over 6, right? At pi over 6, how much was the cosine?
30,
root 3 over 2. So remember this first one was the first coordinate was the cosine of theta. And how much is the sine? 1/2, right? And so that's how we use this unit circle, remember? So what we're going to do is we're going to put the values of this unit circle, we're going to map them on this x and y axis here. Okay, let's familiarize ourselves with this with the x and y axes here. Take a look at this. I've got my I've got my y axis, and it's numbered just like I'm used to, 0, 1, 2, -1, -2. Look at the x axis though. That is not going up by ones. That is calibrated in terms of pi. So if you look it starts at 0, ends at 2 pi. Oh my God, just like the unit circle. If you go around it one time, you start at 0 and you end at 1 pi. If you only go halfway, you're at pi, and oh my God, halfway here, that's a pi, right? In the middle, we've got pi over 2, and then we've got 3 pi over 2. So do you notice how going along this x-axis is the same as going around the unit circle one time? 0, pi over 2, pi, 3 pi over 2, and 2 pi. 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay? So now here's what we're going to do. When the angle is 0, how much is the sine value off of that unit circle?
0.
When the angle is 0, it's 0. When the angle is pi over 2, how much is the sine value? 1. How about at pi? What's the sine value?
Wait, can you just repeat what you just said? That was really...
Okay, so when the angle is 0, how much is the sine value? 0. So y is 0.
What is the y value?
Yeah. When the angle is pi over 2, sine is 1. 1. When the angle is pi, sine is 0. 0. When the angle is 3 pi over 2, how much is sine?
-1.
-1. Okay? At 3 pi over 2. And then when the angle is 2 pi, how much is sine? 0 again.
So we just know that every other one would be 0.
Do we
Yeah.
memorize the unit circle? Should we?
No.
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 So it was 0, pi over 2, pi.
Okay.
Pi over 2.
Okay. We're not memorizing anything, huh?
So it goes 0, pi over
Yeah.
2, pi.
I'm going to tell you guys exactly where we get all those points. Okay? So look at what happened here. So look at where our points ended up. We're at the zeros. We're at a maximum of 1 and a minimum of -1. Remember how we said this, they can't go, right? Yes, okay. I connect, and congratulations, you've graphed your very first sine graph. Fantastic. Okay, now we're going to do the cosine. Same thing, but now the cosine is the first coordinate. Okay, so when the angle is 0, how much is the cosine? 1. 1. When the angle is pi over 2, how much is the cosine? 0. When the angle is pi, what's the cosine? -1. Then 0. Then what? 1. So what points did we hit this time? We hit some zeros. We hit some maxima and some minima. Oh my God, like the same ones as before. Okay? We just made a different shape. And that shape is this.
You made a parabola.
So not a parabola, it's a sine function. It's a cosine function. Okay. In both of these cases, the key word is our points oscillate. Oscillate means alternate. Our points oscillate between +1, 0, and -1, right? +1, 0, and -1. So if I'm at +1, I'm not going to go back, I'm not going to go up higher. I need to go back to 0, and from here I need to go to the minimum. Okay? It's always going to be that way. Another thing we need to watch out for is this. How many points are marked on this x-axis? 5. It's always going to be 5 points on the x-axis. You know what we call these? Critical points. Because it's critical that you put them up there. Okay? On the x-axis, okay, I have 1, 2, 3, 4, 5. Okay. When I'm grading a graph, let's say there are like 6 points awarded to this problem. 1 or 2 of those points will be to see whether you have correctly placed 5 points here. Okay? There must be 5 points, whether you're graphing sine, cosine, tangent, cotangent, secant, cosecant. 5 points.
So, there's always going to be a point in the middle, and then 2 at the ends.
Yes, we start with the ends.
But for cosine,
we
it's
go
always
middle.
going to be 2 on the x-axis for cosine. Always going to be 2.
Yes.
And then for sine, it's always going to be 3.
Okay, let's go here. Let's talk about that. So in the equation, you remember how we said there was A, B, C, D? We're going to do A now. That value A provides a vertical dilation, meaning like if you were to take the graph and like stretch it vertically or condense it vertically, compress it. So if A, the absolute value of A, so if we took A, just the number, ignoring the plus or minus, if that number is greater than 1, so for example, A is 3 or -2 or +4, whatever. So ignoring the sign, if it's greater than 1, then we say there is a higher amplitude.
So we ignore the sign of the
Yes, you ignore it. You just take the absolute value.
The absolute value always makes it positive.
Right, it strips it of its sign. There is a compression if, I don't like the way I wrote this, if A is between 0 and 1, meaning if A is like -1/2, 1/3, and so on, right? So ignoring the plus or minus, if that value is between 0 and 1, 3/7, whatever, then we say there is a lower amplitude.
So whatever is just lower.
Mm-hmm. What is amplitude, you ask? Amplitude is how high or how low the wave goes. How do we measure it? It's not from the very top to the very bottom. We chop it down the middle like this. And now, this distance is your amplitude. Right, so from the center to the peak, or from the center to the valley or the trough.
That's in physics too, right?
Oh my God, it is like so in physics. Okay, so, all right, so here we go. So let's graph a few things that have vertical dilations. First, we're going to describe how these graphs are related. Then we're going to find the amplitude of G, and then we're going to sketch the graphs. I said here to sketch 2 periods, but I'm just going to do 1 today. Okay, here's how I want you to do these. So if you've learned how to graph in another class, last year, whatever, here's how we're going to do it. Okay, here we go. First, I'm going to graph this sine function. All right, I'm going to always give you a grid like this. It may or may not have the x-axis. If it doesn't, you draw your x-axis with a ruler. Now, sine of x, right? We're graphing sine of x. It goes from 0 to 2 pi. Yes? No, you don't have to write it. I'm writing it for me. You don't have to write it in words like that. I'm writing it for you guys to see. So it goes from 0 to 2 pi, which means this is the first point. This is the last point. So I go somewhere here and I put in the first point of 0. Now I count 4. 1, 2, 3, 4, and I put in the last point. How many tick marks do I have total?
5.
Nope, 5. That's the magic number.
You want us to put 0 after
Yes.
the first, like, square?
Yeah, wherever you want, just put 0.
But there needs to be 4. Okay.
Yeah, there needs to be 5 total.
5.
1, 2, 3, 4, 5. Now, start at 0, end at 2 pi. What's the very middle of those two? 1 pi.
Why can't we spread it out a little?
You can spread it out. It's, yeah. What's the middle between the 0 and the pi? Pi over 2. Where are you going? Full pass. Yeah, you gotta tell me first. What's the middle between the pi and the 2 pi? 3 pi over 2. Sound familiar? Okay. Sometimes it's just as straightforward. Sometimes we actually have to do some math to get the stuff in the middle. Yeah. Okay. Now we got our 5 points. Where does the y-axis go? On the 0, right? If you aligned it with the very, edge, then you aligned it with the very edge. It's, it's up to you as long as it's like proportional, ruler, and all that. Okay. Hang on. We are going to graph f of x first, sine. So here's the next thing you have to think about. Am I graphing sine or cosine? Sine. Does sine start on the x-axis or at a maximum? On the x-axis, right? Sine starts on the x-axis. So now I say, okay, sine starts here. Then we're going to oscillate between maximum, 0, minimum. So from here, I go to the maximum, then where? Can I go up higher?
0.
I go to 0, then where? Minimum, then 0. Okay? That's it. Did I plug anything in? No. Sine starts at 0. Yeah. Then I need to put in points between maximum, minimum, and 0.
How do we know the maximum?
They're always either positive 1 or negative 1.
Okay.
For the default. So, up, 0, down, 0. I graph. This is my f of x. I gotta label it. Sound good?
What is like the whole?
That graph, the black, that's sine of x. Now, here I'm being asked for the amplitude of g of x. What is the amplitude of g of x?
4.
It's 4. So from 0, so the first point is still 0. Then I don't go up to 1, I go up to 4, back to 0, down to 4, back to 0. And now when I graph, I want to highlight a very important point. So this is now g of x. Here's the, yeah. Most of the time, you'll be graphing only one function, so it'll be easier to tell them apart. Now, here's what I want to bring your attention to, draw your attention to. The only thing that changed between f and g is the amplitude, nothing else. That means the location where the graph is a maximum is the same. It's just up higher. The location where the graph is at a minimum is the same, 3 pi over 2. It just goes down lower for the amplitude. Look, the zeros stayed the same. Okay, the zeros stayed the same. And we still completed both waves over a period of 2 pi. Okay? So, in real terms, that would be the difference. Like if you were hitting a note, like an F note or a C note or a G, it would be the same note, but maybe a little bit louder, like the volume has gone up. Okay? Okay, so take a look at this. Let's draw f of x first. We're going to go from, huh?
The last one you're looking for G.
Right, again, G. Yeah. So we're going to go from 0, 1, 2, 3, 4 to 2 pi. 5 total points. Center is pi. Pi over 2. 3 pi over 2. Y-axis looks like this here. Oh my God, that looks like a horrible. I will actually take points off for that y-axis. It needs to be straight.
A ruler or
A ruler sounds good. Good plan. Okay, so we have a sign. Where do we start?
it's
We have a sign. We start at 0. Right?
and you just go to the maximum.
So now, once you put in your 0, you have to figure out, is this sine or cosine? And then, okay, so we go maximum 0, minimum 0. And we're going to label that that's f of x.
I like this.
I know, I do too.
How I understand it now.
So, g of x has an amplitude of what? A half. So, is it going to be taller or shorter?
Shorter.
Shorter. So from 0, where do I go? 1/2, back to 0, negative a half, back to 0. And look at what a cute little wave that is. Okay.
We don't have sticky things.
Okay, so on this homework, I actually have the grids for you, but for ones that you're going to do from a book, students do all sorts of cute little organized stuff.
Like draw it.
Yeah. Okay, all right, let's go to a cosine. All right, so I'm going to quickly draw my x-axis. Cosine also goes from 0 to 2 pi. Yes? So I have 0. Okay, you know what? This time, just for fun, all right, I'm going to do what they were suggesting here and spread this out a little. So 1, 2, 3, 4, 2 pi. Why am I doing that? Because I can, okay? So pi over 2, 3 pi over 2. It gives me a little bit more space. It's fine. It's choice. Okay. Y-axis goes here. With a ruler. And, let's not leave it blank. Let's label a little bit. Like, that's good enough. Okay, so now, we're graphing a cosine. Does it start on the axis or at the maximum? At the maximum, for f of x, the maximum is a 1. And then again, we're going to oscillate between maximum, 0, minimum. So I'm not going to go any higher from that. If I do that, then I'm going away from where I need to be. Go back to 0, minimum, 0, maximum. Okay, what that looks like is this. Yes.
You have to, if you're spreading out the x-axis, you have to spread out the y-axis.
No, you don't have to. Yes.
When we graph this,
Uh-huh.
are you okay with us using like colored pens?
Yes. So on the homework, you're only going to be graphing one graph, not two like I am here. Okay? So that minimizes, the need to color code. Okay, what's the amplitude of G? 2. Yes. The amplitude is always the number in front of sine or cosine. So here, I'm not going to start at 1. I'm going to start at 2, 0. Same thing. The location of the minimum at pi stayed the same. It just goes down lower. The zeros are the same. Yeah, we got this. Okay. Reflections are on the x-axis. This happens when A is negative. Okay? And when A is negative, the graph is reflected around the x-axis. Okay? Now, we're going to graph cosine here. All right, x-axis. I'll put y-axis here. Cosine goes from 0 to 2 pi, so we'll make this 0. 1, 2, 3, 4. Pi in the middle. Pi over 2. 3 pi over 2. Okay, where does cosine start?
No, 1.
1. Then 0. Minus 1. 0. Positive 1. This is like, okay. Oh, one thing. You see how the cosine looks, right? Your cosine graph should not look like a V, right? There should be a curve here and at the bottom, okay? All right. So this is f of x. And now g of x, what is the amplitude of g of x? Trick question.
2.
Just 2. Remember, it's the absolute value.
So we still start from positive 2?
No.
Start from -2.
Because there is a negative out front, it's a higher amplitude, but there's a reflection. So I start at -2, 0, positive 2, 0, -2. It's going to look like this, all right, like a little volcano. But now, the amplitude is a distance. And if you go to the when you used to go to the pediatrician and they measured your height, did they ever tell you, oh my God, congratulations, you're at -57 inches today? No, right? Because it's always a positive value. So the distance from the center to the minimum, that's 2. And this distance, that's 2. Cool?
2.
And this is g of x.
Wow.
All right.
Do you write g of x at the maximum point?
Anywhere, just label the graph. Yeah. I had so many markings everywhere else. Okay. Sine of x. I hate it when it's not straight. All right. So we're going to go from 0 to 2 pi. And sine?
0.
Right? So that's how that looks. And the y-axis is in the beginning. Okay, how does -½ sine x look like? Where do I start? At the 0 or elsewhere?
Bottom, like 1/2.
So I start here?
Yeah.
You're sure?
Yeah.
You're sure?
Yeah.
What am I graphing, sine or cosine? Sine always starts on the 0. Then it goes down to 1/2 to 0, up 1/2, 0. Yes. Okay? Oh. See, now that's not even. Okay? And what's the amplitude? 1/2. Way to go, guys. All right? So, the worksheet is what's for homework for next time.
Can we see you tomorrow?
Yes. We have class tomorrow.
Second.